Okay, so hopefully we picked up from yesterday or today's notes, either way, along the way. To be able to solve exponential and logarithmics, you're going to have to be able to convert them. And the idea of why it's related to inverse is exponential and logs. If you convert them appropriately and then go put them in Desmos and graph them, they are the inverses. So you will see the flip in the x and the y. You will see the graph reflect over the x equal y, like visually, if they are converted appropriately. I'm pretty sure in our class video I said the same thing, but some kind of hook lines to help remember how to convert. If we're going from log to exponential, it's base exponent out with your output, and it makes a cursive E. The other thing that I've pulled out in my head to remember is this is an equal, which starts with an E. After equal is your exponent, which also starts with an E. So just some memorizational hooks to be able to know where things go. It's log base B of A is X. So base B is going to be the base, which is why they used to be in that spot too. So exponential, this is a little more of a push, not a little bit of a stretch. It's not quite as obvious as your cursive E. But you are going to push the B down into the basement. So down into the basement. I call this the basement in the bottom because it's sort of a subscript. Then you're going to go grab your of and then end with your exponent. And if I make him real long, that kind of looks like a weird L, like a fat-bottomed L maybe. It's the way I've, again, tried to push that into my brain. But the base is going into the basement. So again, that I call this the basement. Because it helps with a few things, that verbiage in my mind anyway, to make it stick. So your problem, the reason you're going to have to be able to switch them between the two to solve is if you have an exponential when the x is in the exponent. So if you think back to math 1, so like this looks a little more like exponential growth and decay here. When the x is in the exponent, your teacher probably had you put the function in your calculator, like this much of it in your y1, and then you went and used your table and looked for when the x value gave you a 96 as your output. Yay for math 3. It's not always that easy. That is an option, and for that matter, just for backup plans and using your calculators. So the idea, like I said, in math 1 is you would have put this in your calculator, and you can't see that, sorry. So you put that equation in your calculator and then hit second graph and then went and looked for, let's do something else. For 96. So like in this case, it's obviously between 1 and 2, and that's why this doesn't work with our style. Sorry for the gross fingerprints on my calculator too. For our style problems, you know it's going to be between 1 and 2. That's the best you can really do at the moment. So we'll start with this. I'm not going to start with this one. Sorry. We'll back up and go back to this one in a minute. You have to have it in its most simplest form. So base, exponent, output to be able to switch it because I have a B, X, and an A there. Everything else has to be undone before you can convert. So you have to undo before you can convert. Simplest form, then convert. So I'm going to push the base down into the basement. So log base 7. And then we're going to go grab our of. And then it's going to be is our output. Now, log base 7 of 23, you can type into Desmos super simply, and it gives you a number. The other, just for conversation's sake, so you know that it exists, it's called change of base. In case you end up in college or any other math class where they discuss it, you can at least maybe hear the word and remember it. It's because a lot of the calculators originally did not have the log base 7 of 23 functionality, like a TI-83, to where you could change this to a 7. So if you take what's on the top, like main line, put it on the top, basement stays in the basement. If you do log 23 divided by log 7, it gives you your answer as well. I usually go 3 decimal points out just for accuracy. Do whatever your instructions tell you. If there are no instructions, then I would prefer 3 out. So this becomes a number. There is no variable here, so know that even that you can't do it without a calculator, so that's not a thing. This will always be a number. And then you're just going to solve like you did in math 1, 8th grade math. and they usually are pretty easy at this point. So if I subtract 1, so our answer is going to be 0.611, and that's it. I think it's the converting part usually for these guys that give the most trouble. So again, number 2, our base is 7.3. So the part that's always going to be the same is that much. Our base, so we're going to push him down into the basement, which means it's a subscript. And if you write it on paper, it does need to drop down a hair. So like if you're writing on notebook paper, you want to either like write on top of the blue line or just a hair below the blue line for that 7.3 and then come back up. The notation does matter. Again, more of a conversation for if you ever go to another class and you have to show them their work and they're going to be looking very close at your notation, because if it's log 7.3 times 36 all in the same line, then that is log base 10. If there is not a number in the subscript down at the bottom, it is an assumed 10. Just like an assumed 1 when you see an X, the subscript assumed would be 10. And then we're going to grab our exponent. This is our good life because the exponent is the variable. So out here is the variable. So now we can plug that in again into our calculator. And then divide. Oh, I messed up in my calculator. And like I said, Desmos is even probably easier. I would actually recommend Desmos for doing that to get that right answer. And that's going to give me 1.802 equals X. And I would go with the safe bet that you're not going to get 1, 2, 4, 8 very often. Because again, that's looking more at a problem that would have been a math 1 where you could use your calculator and get out of using it altogether. Like you wouldn't necessarily have to do this. You could work the other way. So number 3, again, it needs to be in its base form. So base, exponent, output, but we have an 8 there. That's a problem. We have to address it first. So addressing it first, that's 8 times 3.5. So you're just going to undo it. Use the inverse. So get rid of him. And then so 96 divided by 8. It's going to give me 12. So I end up with the base of 3.5 raised to the x equals 12. Shove the base into the basement. So subscript 3.5 log base 3.5 of 12 is x. So again, basement of 12 is x. So switch into its logarithmic form. And then log base 3.5 of 12. Oh, sorry, I just realized I looked at my calculator and thought I did the last one wrong. That I might have put it in wrong. And then you get that number out, which would be 1.93 is what I'm getting. 984, if I round appropriately, sorry. And then that's your x. All of these examples are fairly like just like that. If there's anything in front of it, you have to divide to get it off. I'm going to skip the next 3, I think, unless you have any major questions. But good. Glad. All right, so then switching to exponential, because this is a log, so we know we're going to make a cursive E. Again, it has to be in its simplest form, so log base of equals output, because I'm going to grab my base, go grab my exponent, and then scoop out with an output. So my base is 27, raise it to 2.4 equals x. And again, the numbers are likely to not be super pretty, because if it was 2 raised to the 4th power, you've done that. You can do 2 times 2 times 2 times 2 in your head or in a calculator, or work backwards, or put it in the y equals and go find the output. So they're not going to typically be super nice, neat numbers. Now that I've said that, you probably are going to run into at least a handful. Don't think you're doing it wrong. Just as a blanket for most, you're not going to get beautiful numbers. And then so you're just going to put in 27 raised to the 2.4, hit enter, and then get your answer. Like I said, this worksheet I didn't put a decision, but I prefer 3, 2 at a minimum, because pennies are everyday life. And we are now in a math where it does significantly matter. Accuracy is the world. So we're not just trying to make our life easy, we're trying to do things correct. So accuracy matters. So number 8, hopefully it makes sense to you when you saw that this 6 is in the way. He's extra. It's 6 times log base 4.6 of x equals 42. So we have to get rid of that 6 first because it's not just log base of on this side. It's 6 times. So we're going to divide both sides by 6. And then we're going to have our equation in the format of log base 4.6 x equals 7. Now it's in its simplest form, and we can easily convert it. Grab our base, grab our exponent, out with our output. So 4.6 is the base, raised to a 7 equals x. Go straight to your calculator. And we should get 4, 3, 5, 8, 9, lots of the numbers, is x. Number 9, we can have more than one thing inside the parentheses because it's still log base 8 of parentheses is, and you're good there. So again, at that point, you're fine. You could have fancy stuff in your parentheses. It's just not fancy stuff outside the main form. So again, going back to like these guys, it needs to be as close to this. These parentheses can get wild and furry in there. And then this guy up here can get kind of wild and furry with some wild stuff in it. But other than that, it needs to be in the simplest form like these two. So number 9, we don't have anything in the front. There's no addition or subtraction in the back or addition or subtraction in the front for that matter either. So we can just take our base, grab our exponent, exit with our output. So 8 to the 4.6. Go out the door, and our output is 60x. So 8 to the 4.6 power. Big old number again. There's all zeros back there, so we'll keep that as is, equals 60x. Not done because x is not by itself. So we still want to get that all the way by itself. That's 60 times x. So we're going to divide by 60. And our answer should be 237.718, or 72 is fine as well, like I said. I'm just a big fan. If you write down more and it happens to be a multiple choice question, I have found that Math 3 students have a little harder time if it's not in the format you're used to. So this is definitely more than they are going to ask for, or at least, like, I've seen thousandth placed, but I've never seen the next one. So if you get in the habit of always doing this, when you look up to look for your answer choice, you should have what you need, because obviously we can round to the 100th place, or you can round or check to see if needed to round to the 10th place if that's what it asks for. But to have to go back and do that work when it asks for the 1000th might be a pain.